Hey everyone, in this video we'll talk about that how we can perform dequeue operation in queue. Let's start. So as you can see in my screen, the poster of a famous movie, we have already discussed about these things. So if we are trying to buy a ticket, then we have to maintain the FIFO or LIFO. You just pause this video and write in the comment section that which order we have to maintain. It's FIFO or LIFO. So I think you have written the comment that is FIFO. We'll follow the first in first out. So we have already discussed about the enqueue method, that is for adding anything into queue. Now we'll talk about that how we can remove or delete any element from the queue. So in queue we have two operations. One is enqueue, we have already discussed about this. Now we'll talk about the dequeue. So at first what we have to do, we have to check that our queue is empty or not. So if our queue is empty, so these two are the same. So at first what we have to do, we have to check that our queue is empty or not. So it means rear equals to front equals to -1. So if rear and front are in -1, it means our queue is underflow. If our queue is underflow, it means we can't delete anything from the queue. Else what we'll do, else if our front equals to rear, then set both as -1. So let's say that 0 1 2, we have 10 here, front and rear is pointing here. It means our front and rear at the same position, so we'll set both as -1. So I'll also talk about the edge case, that is front equals to rear, then set it as -1. So I'll talk about that in the next slide. Else what we'll do, you'll just increment the front counter. So this is the algorithm we have to follow for the dequeue operation. Now we'll see that how we can perform that. So how many values we have here? So we have 5 values. Now what is the value of the rear and what is the value of the front initially? The value of the front is 0 and the value of the rear is 4. So if we perform the dequeue operation, it means at first it will increment the front counter. So initially what is the value of the front? That is 0. After performing the dequeue, the value of the front will be 1. So you can see that front is 1, rear is 4. Now if we call the dequeue function again, then what will be the value of the front? The value of the front will be 2 and the value of the rear will be 4. If we again call the dequeue function, then we'll dequeue this element. Now what is the value of the front? It was 2. What will be the value of the front? It will be 3 and the value of the rear will be 4. Now if you call dequeue again, then which element will delete? We'll delete 60. So we'll delete 60. Now what will be the value of the front? It will be 4. Front will point here and rear will also point here. Now if we again call the dequeue function, then what will be the value of the front? The value of the front will be -1 and the value of the rear will be -1. So why it will be -1? So if we delete this element, it means we don't have any value within our queue. So we'll just set rear equals to front equals to -1. So it means we cannot increment our front, right? Because we don't have any value here. So we'll just set rear equals to front equals to -1. So what will be the value of the front and rear? It will be -1. So I think these portions are clear that how we can perform dequeue. Now we'll see that how we can perform this thing in code. So what is the function for checking that our queue is empty or not? We have to check that if our rear equals to -1 and front equals to -1 or not. If our rear equals to -1 and front equals to -1, it means our queue is empty. We cannot delete anything from our queue. Now we'll see that how we can perform the dequeue. So at first, if our is empty is true, then we'll just print that our queue is empty. Else if front equals to rear, so I have already discussed about this case, that 0 1 2 0 1 2. So this is the value we have. So we have deleted this value, we have deleted this value. Now rear equals to front equals to 2. So it means our rear and front both are pointing in the second position. So if both are pointing at the same position, then it means we have only one value within our queue. We'll just set our front equals to rear equals to -1. Else what we'll do, you just pause this video and write in the comment section that what will be the else condition. Just pause this video and write in the comment section. So I hope you have written the comment. Else we'll just increment the front. We'll just increment front plus plus. So this is how we can perform the dequeue operation in queue. So let me explain this thing again. Let's say that we have 1, 2, 2, 2, 3 or 11, 22, 23. So initially what is the value of the front? The value of the front is 0. Now if we are trying to delete 11, then we'll just check our queue is empty or not. What is the value of the front? That is 0. What is the value of the rear? That is 2. It means our queue is not empty. Then we'll check that our front equals to rear or not. Our front is not equals to rear. So then what we'll do, we'll just simply increment the front. So now what will be the value of the front? It will be 1. So we have deleted 11. Now we'll again check our queue is empty or not. For dequeuing this element, our queue is not empty, front not equals to rear. We'll again increment the front. What is the value of the front? It will be 2. Then we'll check that our queue is empty or not. Our queue is not empty. Now our front equals to rear. What we'll do, we'll just set front and rear equals to -1. So I think this portion is clear that how we can perform dequeue operation in queue. So if you have any doubt, just write in the comment section. Now we'll dive into code. So as you can see in my screen, at first we have declared the queue. The size of the queue is 5. Then we have the rear and front as -1, -1. Then we have checked that our queue is empty or not. This function is for your enqueue operation, and this print queue function is not related to your queue. So I have just added this print queue function only for your reference. This is the enqueue function. I have already discussed about what is enqueue function. If you don't know what is enqueue, just click on the I button and watch that video. And this is the dequeue function. So at first what we have to do, we have to check that our queue is empty or not. If our queue is not empty, then we'll check that our front equals to rear or not. If our front equals to rear, then we'll set our front equals to rear equals to -1. Else what we'll do, we'll just increment our front. So at first we have added 5 values. If we are trying to call this enqueue6, it means we have exceeded the size. We can only insert 5 values within the queue. So here we are calling dequeue function 1, 2, 3, 4, 5 times. So up to this we can dequeue the values, and here we cannot dequeue the values because we don't have any values within the queue. So we can add only 5 values within the queue, and we can dequeue only 5 elements. So let me compile the code. So you can see that at first we have added 1, 2, 3, 4, 5. So these are the 5 values that we have added. So whenever we are trying to call this enqueue function using enqueue6, then we are getting that queue is full, and we are deleting the elements from the first position, that is FIFO, first in first out. So at first we have dequeued 1, then we have deleted 2, then we have deleted 3, then we have deleted 4, and at last we are deleting 5, and we are getting that queue is empty. So here we are also getting that queue is empty because we have deleted all the values from our queue. So I think these portions are clear that how we can implement dequeue in queue. If you have any doubt, just write in the comment section. See you in the next video.